Please subscribe our channel Education Point and press bell icon to get notification of new educational videos.
Hello everyone, welcome to lecture number 105, and today I am going to discuss the structure of fructose, especially the open chain structure. And here, on the basis of few reactions, they are very important reactions for open chain structure as well as for functional group like hydroxy group. So to discuss this structure first on the basis of elemental analysis and molecular weight determination, it is found that the formula of fructose is C6H12O6. It means it contains 6 carbon, 12 hydrogen and 6 oxygen. And these atoms, hydrogen, oxygen and carbon, in what form they are existing in sucrose. Number 2 is when sucrose is subjected to acetylation, that is when it is treated with acetic anhydride, we get acetyl derivative where 5 of the hydroxy group is changed into acetate. This confirms that sucrose is having 5 alcoholic group, hydroxy group. And secondly, the 5-acetyl derivative of fructose is very stable. So this confirms that all the hydroxy group in fructose are on different carbon atom. So this reaction, acetylation, gives two information about the structure of fructose. And let me tell you, sometimes students may expect such type of questions in exam. For example, how will you prove that there are 5 hydroxy group or alcoholic group in fructose? How will you prove that these 5 hydroxy groups are on different carbon atom? How will you prove that there is keto group, not aldehyde group in fructose? And then sometimes they may ask, how will you prove the ring structure and open chain structure of fructose? So these questions are expected in exam for undergraduate students. So the third reaction, when it is subjected to reduction in presence of sodium amalgam, then it is changed into hexahydric alcohol, and that one is again when further reduced in presence of hydroiodic acid, then it gives 2-iodohexane. So this reaction confirms that fructose is 6-member and all the carbon atoms, they are open chain. And then the next reaction shows that is formation of osazone, and that fructose gives fructosazone. So the formation of osazone in presence of hydroxylamine confirms that fructose contains carbonyl group. And still it is not clear this carbonyl group is aldehyde or ketone. That I am going to confirm on the basis of oxidation. When fructose is subjected to oxidation, first thing, fructose will not react with mild oxidizing agent like bromine water. But when it is treated with concentrated nitric acid, that is a strong oxidizing agent, there will be breaking of the carbon chain, and there will be C2 and C4 acid, that is glycolic acid and tartaric acid. And this reaction oxidation confirms that at carbon 2 there is keto group. Only when there is keto group, then splitting up carbon atom will take place. So here I have given you all these reactions. For example, that is open chain structure of fructose. Number 1 is the elemental analysis and molecular weight determination has given the formula, that is C6H12O6 for fructose. Number 2, it forms pentaacetyl derivative and hence contain 5 hydroxy groups. Since fructose is a stable compound, it shows that hydroxy groups must be linked to different carbon atoms. Number 3. When reduced with sodium amalgam, it forms hydroidic alcohol, which on complete reduction with hydroidic acid gives 2-iodohexane. This shows the presence of a normal 6 carbon chain in the fructose. Number 4. Fructose forms fructosazone, and therefore it contains carbonyl group. And let me make it very clear here that osazone formation takes place, corrected, in presence of phenyl hydrazine, and in presence of hydroxylamine the oxime formation takes place. So here osazone formation takes place in presence of phenyl hydrazine. First it is converted into phenyl hydrazone, and another second molecule it will consume, then it will be converted into osazone. It is good, it comes like this, huh? Number 5 is the oxidation of fructose with a strong oxidizing agent. And I told you that on oxidation it gives 2 products. One is called tartaric acid, that is C4, and other one is called glycolic acid, that is C2. And this breaking takes place at carbon number 2. Here it is shown very clearly, this is your fructose, and this dotted line is showing that that is when oxidation is taking place, then the breaking will take place from here. That breaking is only possible when there is keto group at carbon number 2. And this is the difference in aldehyde and ketone, that is glucose and fructose. In the case of glucose, when it is treated with a strong oxidizing agent, glucose gives saccharic acid, that both ends will be oxidized and both ends will be converted into carboxylic acid. That's why we will get dicarboxylic acid. But here the both ends are not oxidized in dicarboxylic acid, rather than the breaking will take place at carbon 2, and that is the confirmation that fructose is having keto group. This is a confirmatory test. So here I have given you, on oxidation fructose gives a mixture of tartaric acid, that is containing carbon number 4, and glycolic acid, that is carbon number 2. This reaction is the characteristic of ketone and shows that the carbonyl group is present next to one of the end carbon atom of chain. And here the dotted line shows where the bond breaking occurs during oxidation. Number 6. When fructose is treated with hydrogen cyanide, cyanohydrin will be formed, and finally on hydrolysis in presence of hydroidic acid, it gives alpha methyl caproic acid, and alpha methyl caproic acid is only possible when there is keto group. So this is again one of the confirmatory reaction to confirm that fructose contains keto group. So these two reactions, oxidation and cyanohydrin caproic acid, is the evidence and confirmatory reactions to show that fructose is having keto group. Here the reaction with HCN giving cyanohydrin, which on hydrolysis gives alpha methyl caproic acid. This reaction also proves the presence of keto group in the fructose, and reaction is given here. Fructose plus HCN, it will give you cyanohydrin. When it is treated with hydroidic acid, during hydrolysis it will give alpha methyl caproic acid. So on the basis of all these reactions, we can construct the structure of fructose, that is as such. Here I have given you CH2OH, CO means it is keto group. CHOS, 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 CH2OH. This is your open chain structure of fructose. So in this way, I have concluded with all the reactions, giving the full evidence about the open chain structure, and here not only open chain structure, also you have got the confirmation of the presence of keto group on the basis of reactions. Thank you very much.